Welcome to another episode of Dinosaur Parkour. I'm your host, Chris P. Fried. The topic of this video is Linkage Section. Explain. The linkage section in a COBOL program defines the layout of memory passed from another program, generally via the call verb. It also defines the layout of memory to be acquired at runtime via some form of a get memory function. Some examples of get memory functions are get main routine, written in assembler, the language environment get storage API, or the COBOL allocate verb. In assembler, the equivalent for a linkage section is called a DSEC, or dummy section. And such a name implies that the linkage section is not real. So the linkage section defines the layout of memory that becomes available to the program at execution time. And in other words, the programmer has to write code to access or acquire memory at execution time. Any testing was done using IBM Enterprise COBOL 6.3. Most of what's explained in this video applies to IBM Enterprise COBOL 4.2 or prior. But however, the allocate verb mentioned a minute ago is a new feature introduced in COBOL 6. Linkage section as defined by the Cambridge English Dictionary, the existence or forming of connection between things. This is the definition that I think the architects of COBOL had in mind when they came up with the name linkage section, the forming of connection between two programs. The most common reason to use the linkage section is to define the layout of memory structures passed from program A to program B. When program A, called program B, it can pass data structures. Program B uses the linkage section to map the data structures that are passed by program A. However, that is not a complete answer. The linkage section also handles connecting a JCL step to a COBOL program via the exec parm equals keyword, IMS connecting to a program via the program communication block or PCB, CICS, EIB, and the COM area, memory that is acquired at execution time, which is technically not connecting to programs. But what all of these examples have in common is that the linkage section is used to define the structure of memory that is not available until execution time. What does the linkage section do that allows two programs to connect? Is the linkage section required when program A invokes program B? The answer is no. The linkage section is not required when program A invokes program B. On this slide, demo program called A31BR14 and does not pass anything. The using is not used on the call verb. A31BR14 does not expect anything to be passed to it. The linkage section is not required when program A calls program B without passing data. Maybe the linkage section is an optional participant that is needed when data is passed from program A to program B. This slide shows program A passing data to program B. Again, the linkage section is not required. Consider the subprogram A31BR14. It's a version of IEFBR14 that was generated as AMO31. This was done so that the COBOL program can invoke it without using the compiler option data24. I used it to trick the compiler when testing snippets of code. With that in mind, consider demo program. If I'm testing a COBOL verb using data1 and data2, and those data items have value clauses, the compiler considers them to be constants if the fields are not modified. Thus, the compiler generates the test code assuming the constant value. In other words, it hard codes the value into the generated code, which might not look like the actual generated code if the fields were considered to be variables. To trick the compiler, those two fields are passed to this AMO31 version of IEFBR14. Because of that call statement, the compiler flagged data 1 and data 2 as being variables. The compiler does not know that A31BR14 is a do-nothing program, so it assumed that data 1 and data 2 were changed. Now the compiler is more likely to generate the test code and demo program like it will be in the production program. Now, this assumes that you match the production compile option, which also impact the generated executable code. To answer the question, is the linkage section required when program A passes data to program B? No, it is not. If program B does not care about the data, the linkage section is not required. That's in the case of A31BR14, it purposely does not care if data is passed or not. Finally, the situation that explains when the linkage section is required. Program A passes data to program B, and program B needs to use some or all of the passed data to perform correctly. Looking at program B, it appears that B only cares about data 2. Why was data 1 mapped? Because the using statement must sync up to the pass item that the program B cares about. Since program B cares about data 2, it has to map the fact that program A passed data 1 and 2. Many programmers say the using statement between the two programs must be 100% in sync. They only have to be in sync up to the last data item that the subprogram cares about. This slide shows what I mean. If program A passes 3 data items and program B only cares about the second one, program B has to map data items 1 and 2. And data item 1 does not have to be mapped correctly. Program B does not care what data item 1 looks like, so it defines it as pick A. It does care about data item 2, so this data item has to be defined correctly. Notice that the order in linkage section is backwards. This is okay since the linkage section is a template to be placed on top of real memory at execution time. The demo program is passing 3 items, but program B only has to map the first 2 since it cares about the second item. If you're new to COBOL, some of this might be confusing. However, the target audience is programmers wanting to be better COBOL programmers, so I want people to understand the reality of what's happening. In the spirit of reality, I've been using the phrase passing memory. In all of the prior examples, demo program has not been passing memory, it has been passing a pointer to where the data structures reside in memory. This passing of the pointer to the actual data structure is known as by reference, and there are 3 ways data can be passed using the COBOL verb. The first way, and by far the most common, is by reference. It's also the default way. Passing a pointer to the start of data in memory. This allows the subprogram to update the data owned by another program. Program A calls program B passing 2 data structures. Any update done by program B is actually updating the memory that belongs to program A. The second way is by content. The call statement makes a copy of the data structure and passes the pointer to the start of the copy. Program B is accessing the copy of the data structure. The original version cannot be updated since a pointer to a copy was passed. By content is more expensive to use since the call verb has to create a copy of the data structure prior to invoking the subprogram. The third way is by value. This passes the value. Generally speaking, you can pass a single character if the value is alphabetic or alphanumeric. If the value is numeric, values up to 4 gigs can be passed. Complex structures cannot be passed. Basically, you can pass anything that can fit within a full word. By value is used to interface with programs written in C or Java. This slide shows the demo program calling program B and passing two data items. The memory for demo program is shown at the top. Data 1 has data that says this is the data for data 1 and is a light blue color. After that is other data, which is a gray-white color, and the content for data 2 is the burnt orange color at the end. Notice the order of data 1 and data 2 in program B's linkage section. They're backwards. Data 2 is listed first, followed by data 1. Remember, the items in the linkage section are like a template. They overlay real memory at execution time. How the data items appear in linkage does not matter. The using statement controls the order. The call statement in demo program is creating a list that contains two pointers. Pointer 1 points to the start of data item 1, and pointer 2 points to data 2. The procedure division using in program B places data 1 over what pointer 1 points to, and it places data 2 over what pointer 2 points to. The using between the procedure division and the call statement must match. A line was added to program B. We added move info to data 1 dash word 4. That move statement replaces the word data with the word info. The memory that is owned by the demo program is updated. Program B is updating the working storage memory owned by demo program. If you have mostly played with object-oriented languages, this might make you cringe, but this passing of pointers and allowing subprogram to update another program's memory is one of the reasons why COBOL programs are able to run faster than object-oriented programming. Here's a recap. The linkage section is primarily used by subprograms to define data that belongs to a program higher up in the calling chain. Now, some programs will require memory at execution time, and the structure for how to format the memory is defined in the linkage section. Memory for unbounded tables is an example. And unbounded tables are a cool COBOL 6 enhancement. Data structures that can only be mapped at execution time, such as ZOS control block, will be described in the linkage section. So I hope you have a better understanding of the linkage section and what it really does. Thank you for listening. This has been another episode of Dinosaur Parkour, faster, better mainframe programming.